Okay, so ABNcast is taking its studio out of its usual North London base, and we've been down at Farnborough Airshow this week, talking to as many people as we can about the future of the aviation industry. I'm delighted now to be joined by Mike Slack. Mike Slack works for Ansys. He's going to tell us in a minute about what Ansys is all about, why they're here, and the kind of conversations that they've been having with the aviation industry. So welcome, Mike. Thanks for joining us on ABNcast.
No, thank you very much. It's good, to be here.
Let's start with that. Ansys, what are you, what do you do, and what's your role with the company?
Okay, so I'm a technical account manager, and I specialise in the aerospace and defence sector, and I have obviously a very keen interest in sort of sustainable aviation and some of the new directions that we see our customers directing their engineering interests in. So we're trying to get a good feel about where that's going and how we as Ansys can support them. So that's one of the core things. And one of the things that we're obviously seeing is that there's a whole range of new aircraft formats being evolved.
You're seeing a lot around on the show today,
So you're looking at sort of eVTOLs, taxis, drones. We're talking about drones for delivery systems. It could be sort of emergency services. There's a whole range of different business models happening with these different aircraft formats that are coming out. And at the same time, we're also being challenged to become more sustainable, reduce the carbon impacts associated with traditional aviation. And all of these are introducing lots and lots of new engineering questions, engineering challenges. But also, we're no longer looking at things from an incremental development perspective. There's new business models, and you need to make sure that your design achieves those business outcomes. So how can you?
So when you say not incremental, that incremental is that kind of marginal gain, slow steps toward an end goal. What you're saying at the moment is that in different areas and different reasons, there are big leaps to be made, and they will happen quickly and in one go, and that can be disruptive. It could also be transformative.
Yeah, and I think it's a big leap, and we need to make those changes quickly in order to bring these things into the marketplace.
There's a sense of urgency, is there?
I believe there's a sense of urgency, and I think we're seeing those pressures. We're seeing those pressures from governments. We're seeing those pressures from consumers as well. So I think the industry sector, has to start to address these and do its best.
And the industry's putting pressure on itself. I mean, it's telling the public 2030 we want to be hitting certain targets on CO2. By 2050 we want to be net zero. There's a lot of doubt whether that's possible, but it is going to be the engineering that helps them achieve that. It's not going to come out of nowhere, is it? So no. This is the key discussion.
No, and I think there's a combination of challenges. It's not just even the aircraft design. It's like there's going to be no one size fits all. I don't think. No. I think we're going to have to tackle the sustainable challenge by looking at a range of solutions and choosing which solution fits which aircraft concept appropriately. So, I mean, obviously with sustainable aviation fuels, that is a good solution, and it will be part of the journey, but it's also quite energy intensive, or it requires lots of land to create vegetable-based products to develop the sustainable fuels from. So we've also got the ideas of hydrogen, we've got the ideas of electrification, so and hybrid electric. So I can quite easily see sort of the electric side of things working very well for those drones, and you can see that taking shape. Those are going to evolve. But then with the change in fuel types, particularly if we were to look at a hydrogen solution, it changes the entire sort of makeup of the aircraft, and that's where we're coming from with the not being
put that into the existing hardware. The hardware then has to adapt to the fuel type, essentially. Yes. And it needs infrastructure as well for something like hydrogen. Whereas for SAF, you can deliver the fuel in the infrastructure that's currently available at airports. So that is seen as the interim, or certainly the most promising short-term answer. It's actually availability that's the key. And you said you may have to find a lot of land to grow the organic material, but we've spoken on ABNcast actually to a couple of companies. One's trying to make SAF out of household waste, the other one human waste. There's all sorts of clever
solutions.
Things happening.
And all of these are engineering challenges. There's engineering
but all possible.
And I think that's the fun thing. Or as an engineer, I use the word fun because it's we like to solve questions and we like to solve challenges, but I think it's very important to understand and focus what we're trying to solve. There's no point just in taking this part of an aircraft and refining its design so that as much as you can. What we need to start looking at when we're looking at new concepts is how does this system interact together, and there's lots of multidisciplinary challenges within one of these concepts. So if you're looking at drones, you've got control software, you've got autonomous flight design that needs to happen, you've got electronic components that need to be cooled, you've got the aerodynamics of a system. So when we put all that together, you can solve challenges with different parts, with different disciplines. But so the next challenge for the engineering teams, which have been potentially a bit disparate, is how do we make them work together? Right. How do we develop that systems perspective so that we can guide the engineers to what level of detail do they need to solve their particular aspect of this system design? And I think this is where Ansys want to become a lot more involved.
And this is about the sharing of data, but the use of that data. Collaboration is a big word, easily said and hard and difficult to do.
Well, the flow of data between the engineering disciplines is also going to be quite important. So, I mean, we have traditionally been on the sort of the high fidelity side of the answers. We can dig down deep, we can help you design that thing, but it's knowing what level of detail to work on. And you also have to realize that if somebody within this engineering team cannot reach their goals, how can we mitigate it? How can we manage that risk? Maybe with another part of the engineering system design. How do we communicate that back round the loop to get those people? So this is where we move into sort of the talk about sort of digital engineering. And Ansys, we're not claiming to be everything that is digital engineering. We are part of that system, and we want to integrate into or work with our customers to make sure that our tools integrate. We're developing sort of very open APIs so that we can be linked into these systems, so that we can also help support and manage those data flows from those tasks.
There's definitely a lot changing in engineering, and it's technology driven. So concepts like immersive engineering and the software becoming a bit like I think we've seen in automotive, where if you look at, I mean, I have to say, after Tesla that transformed the car industry, how that product, it's a car, you can look at it, it's definitely a car, but if you look under the bonnet, it's nothing like a car. It is run by its software now, and the software is, you can't really strip the software out. Strip the software out, you haven't got anything left. It is what it is. This is, I mean, an airline's aircraft are the same. They're, as someone said to me earlier in the week, they're flying computers now. So and you start almost with the rather than the hardware determining how the software works. It's kind of
I mean, the way we look at it is we look at the requirements. And we look at that system picture, and then we distill that into a systems architecture, and then from there we can auto-generate some of those softwares. So you're no longer reliant on people actually developing and writing the code where mistakes can happen, because the very, very complex systems that we're talking about, we need to build in as much automation as we can to reduce error, because we can't bring that in. So if we can do automatically generating certifiable code and link that back into and test it within the whole system, so you can validate it, that's another thing that we can bring to the table here.
So to go back to what you're saying about what the future looks like with different solutions for different parts of the sector, when you look at the future of aviation, are we going to have a kind of more of a patchwork quilt type of aviation sector where, some short haul stuff will go electric, hydrogen will be good here, this will be pilotless, potentially, more complicated by the sounds of it. Is that fair, or is there a simplification here as well that's going to happen?
Yeah, I think if you think about this, we're in. You could be put off and scared by the sheer complexity of everything, and I think the key thing here is we have to develop those engineering workflows. We need to build that connectivity, and where appropriate, we need to build in the automation into those systems. Otherwise, it's just going to be too big a challenge, and it will take too long to happen.
Yeah.
And we need to reduce those potential risks, because we're also working in an industry where we have to, the safety is it's a no-risk industry. So we have to be able to demonstrate and document what we've done, how we've done it, and the data flows associated with that. And what we've done and achieved, and how we've achieved it, also has to be mapped out and captured as well.
Yeah. So, talking before we started recording about this, the impression you get is that this is one of the great engineering challenges of our time, maybe ever. But it puts a smile on your face, because it's the kind of thing that, as an engineer, you want to get your teeth into.
Yeah, I mean, it's exciting. I mean, I would say it's a very good time to be an engineer. I think we need to encourage younger engineers into the sector, and they need to be thinking in, these new ways, the new paradigms of how companies will move forward, and it's going to be the companies that adopt some of these practices that will. I would like to think they're the ones that will produce the products which meet the business requirements.
It'll change the world. I think you probably don't ever expect. You think about how things have changed in other sectors, maybe even just tech and mobile phones, for instance. The iPhone's only 20 years old, I think. A bit more than that. Yeah. And you look back and you think, how the hell did we do this before the iPhone?
Yeah.
How did I arrange to meet people? And you can't actually remember. You must have used the phone, I guess. I don't know. Yeah. I can't remember ever phoning anybody. And that just shows how quickly the paradigms shift and change.
Yeah.
And aviation, you can see, is probably on the cusp of that now. I mean, it's not beyond reason to think that in that sort of time frame, you're going into London and you'll just as much get an air taxi to the next meeting as you would jump in a black cab. Yeah. Look at places like Dubai, which are really pushing ahead of this, and you can very much see pilotless drone taxis flying around people to the rooftops of the skyscrapers out there.
And I think we'll see things pivoting very fast, as you say. You no longer arrange to meet your friend and then had to stick to it. You can change on the fly and make a correction, and that's the same thing. Things will move fast, things will evolve fast.
Yeah.
And
the technology of engineering, I've seen a few demos of engineering in the Metaverse. It's essentially what it is. I mean, they may call it not Metaverse, because that conjures up certain ideas, but that's essentially what it is. It's engineering in a virtual world before you then take it into the real world and test things there. This is probably where the speed is going to come, the accuracy maybe.
Yeah, I think we shouldn't negate the sort of the physical world as well, because on the physical assets you're going to be generating and capturing more data.
Yeah.
And this is the challenge with learning. If we can get that data and use it effectively, we can also learn from it, and we can refine our models. So, in-service information, operational data can all be fed back into it. So everything we design up front should also be used in the aftermarket and after service, because it gives you insight, which can now be, and there's business models you can build off that.
Yeah.
You can advise your customers, fly in this way.
Yeah.
Or maintain this at this point. It will give you a commercial benefit. But we need to know how they're using those assets, and we may even, there may be other opportunities and other business models about how you license that thing. Depending on how it's going to be flown, used,
and that's
serviced.
Actually a key topic. We have our own Predictive Aircraft Maintenance conference every year. This year will be in Dublin in November. Yeah. Exactly what they talk about there. All this data is being spewed out of every flight.
Yeah.
What we're doing with it, what we're using it for. Are we being clever at predicting what's going to happen before it happens? Yeah. Because we can operate more effectively and efficiently. And then that does come down to a kind of, I guess, outside of the engineering side. For aviation at the moment, coming out of COVID, took on a lot of debt as an industry. Famously, IATA will tell you, aviation doesn't give you great return on capital investment. It's a resource-heavy industry. It's an expensive industry to be in. So the onus at the moment is on the industry to be working more effectively and efficiently, and this is where the answers can lie. Do you feel at the moment, the conversations you've had this week, there's a real desire to do that now because of what's gone on in the last few years? That sort of COVID put a line in the sand and say, we've really got to now grasp this?
I don't know whether it was just COVID. I think there was a trajectory. I would say there was a trajectory on the sustainability anyway that was going to have to happen.
Yeah.
We already saw that. I mean, from my perspective, maybe COVID has presented us with additional challenges because of the.
I guess sustainability is the same thing, isn't it? Sustainability is being more efficient, using less resources. That's what sustainability really is. It may be different kind of fuels, but it is also the same aircraft with the same fuels, just operating more effectively and efficiently, and as we're seeing with the new aircraft coming through. So.
I don't think it's bad to challenge ourselves to do things better and more efficiently. That's
be less wasteful.
Be less wasteful. I think that's. And that's how we would want to support the industry. And we can already see that people are revisiting. They can revisit their existing designs. How can we work better with sustainable aviation fuels? What are the impacts this is going to have on us? Does that change the way we may have to maintain our operations?
You mentioned earlier on, excitedly talking about the challenge and the engineering challenge in the industry, about how that you feel that should really enthuse a young generation of brains out there who want to apply themselves to something that's really cool. Do you think that's known well enough out in the industry? There's a clear problem with lack of talent at the moment in across all sectors, to be fair, but aviation's got to compete. Do you think it's sort of aviation is seen as being that industry where you can do this kind of thing, and if not, what can the industry do to make sure that the next talent really understands aviation is where they can have a great career?
I would say that a lot of these things that we're talking about might not have filtered down into. I know
schools, colleges, universities.
To the people making those decisions at the school level. Certainly there are universities that are doing lots of research in this area, but I think maybe we need to go down a level to the sort of the potential students and say, hey, these are some of the things that could interest you, especially if you've got an interest in improving or supporting the environment. Look at engineering from not just designing a racing car faster, but how do we extend life? How do we build the circular economy? How do we link everything back? How do we take information from the current in service to make our calculations at the early concept of saying more accurate? How do we use AI systems to make those calculations faster so we can use them in a different way? Instead of waiting for hours, we may have AI developed, AI learnt from simulation, which can now operate can be answered in split seconds. All of a sudden, that information can now be used in a different way, and we need people to think innovatively.
You mentioned AI, and obviously, essentially, AI promise. It could be doing all this stuff. You don't need a human being involved. Is that really the future, or will there always be something that a human brings to this that an AI will never quite emulate?
My own,
you hope so.
My own opinion is that when humans, we're very good at developing tools. We never work less hard. So when we invented an axe, we didn't just chop the one tree down, we chopped more trees down. So when we develop AI, when we develop these tools, what we tend to do is ask more questions of them.
Right.
So there's still a huge amount of engineering that will be done. We will now be given more things. Maybe I can use a different example. I mean, rather than the axe, but so if you imagine, you have AI on your phone, it focuses your camera, and you can take photographs. Did people take less photographs because they got it right first time? No, they're taking hundreds and hundreds and hundreds of photographs.
Because they're so good now.
Because they're so good, and they're being stored in the cloud. We develop these tools using artificial intelligence. We develop these tools. We do more with them. Right, and that is what we will do. Once we have confidence in them, we will use those tools to invent. We'll use those tools to innovate. And I don't think people need to be scared that they will be replaced. I think we just need to learn how to interact with these tools, and we will do innovation faster. Better.
You alluded a minute ago to sort of high fidelity automotive, maybe sort of Formula One or something like that, but engineering at an incredibly high pace. highly regulated as well, sector like that. But results driven, clearly, it's a sport. And they're using all this. The AI is designing their parts. AI is being introduced to do all sorts of things. They've got 3D printing for parts and all that stuff. So they're pioneering at that edge. Is that something that aviation is coming on behind or on the back of?
I think aviation has got some of it's got some very, very capable engineers in it. They're world leading. Yeah. And I mean, you mentioned additive or printing and things like this. So new manufacturing methods is another part of this challenge. So, if you imagine, we can now we don't have to manufacture things and assemble them. We can manufacture an assembled system. Yeah. So we need to think again. It's transformative. You need to. It's not just about we could only machine in that way. We can now build things which were different. Yeah. So again, we have to make another step.
And that's something like that has got the ability to completely change the supply chain setup. At the moment, we've got supply chain issues because we're reliant on large producers in parts of the world, and if there's an issue there, you just simply can't get hold of the parts.
Aftermarket.
3D printing changes that
aftermarket as well. You want to retrofit a design. You have a slight. You recognise a discrepancy in your design based on some in-service data. You can retrofit a design and print something in location and install it to mitigate something. Yeah. I mean, there's still challenges. We still have to overcome our understanding on the materials aspects of these things. We have to understand a bit better about lifing these components. But again, these are all challenges that where Ansys can
an example
get involved.
Where one side of the industry is answering one question and causing an issue elsewhere has been on the use of composites. So the modern aircraft, with the use of some of the new materials that can't be recycled at the end of life. So it's great for the OEMs because they've created a lighter aircraft, but they've just pushed a problem down the line. I guess what you have been talking about in this sort of more ecosystem collaborative ways, that you don't have those issues anymore because you're thinking about the entire life cycle.
Yeah, I think that's certainly something, and doing almost like a sustainability inventory of your aircraft as well, and I can certainly see that coming as a legislatively. In order to get your aircraft or your product certified, you may have to present this is my sustainability materials inventory. This is what how we will work them. This comes back to that data. I'm talking about having that data. So you want to have the information on the materials data through the concept all the way through to the end of life. Yeah. So how do you track that materials inventory? Yeah. How do you make sure that we've learned something here? How do we do it better next time round during round the loop? So again, that's one of those digital threads of data that I was referring to at the beginning. Yeah. Just the materials data. That is one of your authoritative sources of truth. Where is it?
There's always an issue with data in any ecosystem where there's lots of stakeholders, and data potentially is useful to everybody. Still, someone thinks it's theirs and they don't want to share it. That's a cultural, maybe. It's a commercial thing. Are there answers to that? Yesterday, for the first time in a long time, someone mentioned the word blockchain to me. That obviously was something everyone was talking about for a while, and then it went away for various reasons. But there are potential answers to this if you want to share data.
Absolutely, and different ways of encryption. I mean, we at Ansys, we have that can come back to the AI system. Yeah. The AI bit, you can build a reduced order representation, which captures the behavior of your particular subsystem or design, and you can then provide that to your customer as a functional mock-up unit or an FMU. I don't know if you've heard about these things that they can then plug into their concept system. Right. Plug it in your asset and play it through and see if it fits. Yeah. And then they can feed back to you if you need to make a change. They don't need to know the IP of your product. Yeah. So they don't need to know the material. So I think when we start looking at these new digital engineering ecosystems, then that will come into it. There needs to be an openness, but we also need to look at how do different parts of the supply chain interact and work together. And again, this is the type of thing that Ansys, we address this through the way that we can consolidate the information using our machine learning systems and build those into aspect components or FMUs, reduced order representations, meta models, and provide them. You need to trace it as well, so you know which one was being used when. But again, that's the data management side of
without which none of this stuff is going to happen.
We have to make all that, bring all that together as well.
So we're 2.5 days into Farnborough. You've got a number of people, I'm sure, coming through the doors of the chalet. Airlines, all sorts of manufacturing companies. What's been the general theme of the conversations? People being positive when they come through. They're looking for answers.
I mean, from my for me, I think everybody's open.
Yeah.
I think that's the big thing that we see. Everybody's open. We are people are learning from each other. I think that's another thing that's very important from this show. It's like, how do we, and it's about sharing, because we have our ideas and bringing them out here. Not everybody knows what we can do, and I think, and we might not know everything that they need. So I think that partnerships that we can create with the customers that we meet here is one of the key things for us moving forward. Moving forward together with our customers, because we are one of those components in that big ecosystem that's going to.
There's a lot of learning going on.
There's a lot of learning, sharing, education, and it has to be both ways.
Just final thought before we wrap up on just where you think we are. I mean, are we at the start of this? If we let's say we're here in 4-6 years' time, are we on the cusp of rapid change in the industry? And so we'll sit here in 6 years' time, we'll be looking behind us and see a completely different range of aircraft out there flying around and being demonstrated. Or will it be slower than that? And in 10 years' time, we'll look back and go, "Oh, that went quick." When you're within rapid change, you never know about it until you look back. Really often, isn't it?
Until you look back. But if you think about where I've been working in this sector for sort of 20 years, and it's been accelerating. All the time. And I think we're seeing. We probably couldn't have imagined autonomous flying drones 20 years ago. So those things are now becoming much more mainstream. I think we'll see the application of these things. We're going to see, new concepts. We've got airships being built in the UK. So we see the UK really standing up. Now, don't we? In the aerospace sector.
Okay.
So.
That's an interesting one. UK is known for its innovation, not necessarily taking those things into mass production, but we seem to be quite good at inventing the ideas. Where when you look around the world, where do you think the hubs are going to be where these new ideas are really going to take root? Is it the UK? Well, obviously Silicon Valley is an obvious case point, but clearly looking east where things are developing in that part of the world.
I think within Europe, we've obviously got a lot of the legislative challenges pushing us as well. So I think that is going to, force some of the questions, on the sustainability issue, on the materials, those sorts of things will.
And that will set a standard for the globe, really, won't it? That tends to happen.
And I think, things like on MRO, I think, some of the British standards that are being developed, are actually, we're getting in there and we're writing them ahead of other people. So or we're developing and building our thinking in that way, and that then influences international things. If you look at sort of electrified flight, EASA 2 years ago published a document that said, we will have to certify these things, but we all have to work together. We all have to help each other understand what we need to do to develop this certification. And for me, with simulation, it helps you explain things. And I think if we can support the explanation about how we've developed something, how we've designed it, why we've done it this way, that gives additional credibility and to the certification agencies. So
that was a topic again at our PAM conference last year. We had some regulators on a panel, and it was as much. But we need educating as to what you're doing as much as anything else, because we need to be brought along with you.
Absolutely.
Otherwise, we'll just sort of go, well, we don't do it in this way. That's how it. That's not how it's done, and you can then become a blocker rather than an enabler.
And how can these certification agencies, understand both the limitations of simulation, but also where simulation can give them confidence. So I think that's something else, because you're going to have so many questions to answer on these new systems, because we're not moving incrementally. We're going to have to consolidate all the information we can to make the justifications, to convince, to make sure that everybody knows that this asset is going to operate safely. So working with the certification agencies on building their confidence, I can see our tools playing a part. It won't replace test, completely, but it will support it.
Yeah, provide confidence. Yeah. Our time is sadly up, but thanks for that. It's great to speak to you and someone who's obviously so passionate about this side of an industry, which at the end of the day is at the core of what we're here for. This week. So it's been a pleasure to speak to you. Thanks for joining us on ABNcast.
No, thank you very much.
We are delighted that our friends at Amadeus have agreed to be the launch sponsor for ABNcast. And while they do not endorse the views and opinions expressed, they are keen to support a new forum for debate around the future of aviation. Today's traveller expects to be wowed way before they arrive at their destination, and passengers want a smooth, effortless journey, combined with exceptional personalised experiences. Embarking on such a major transformation to become traveller-centric retailer isn't an overnight journey though, so how are airlines adapting? Well, you can discover how they are seizing the opportunities afforded by new technology in Amadeus's Travel Technology Investment Trends 2024 Airlines Report. Key findings show 50% of full-service carriers are planning to spend more on technology this year than in the previous year, and 58% of low-cost carriers cite innovation as the top technology investment driver over the next 12 months. In the report, you'll also discover key objectives driving technology investment for both full-service and low-cost carriers, aspirations of airlines on the journey to modern retailing, and the technologies expected to make the greatest impact on the industry. You can download the full report now on www.amadeus.com. Just go to the Resource Centre and you'll find it in Research Reports. And don't forget to subscribe to ABNcast on our YouTube or Spotify channels to make sure you don't miss future episodes. Thank you very much.